Let's have a look at adoption potential in reefonomics. So first of all, we'll set up a scenario to test this on. And so whilst I'm going through this scenario creation, describe the adoption approach. So generally the idea with adoption is that something less than the total number of available landholds is going to adopt an activity. So for example, if we've got 100 hectares of activity, but the adoption likelihood might be 60%, well, we'll end up with 60 hectares, and then we've got a time to achieve that adoption potential, which might be 10 years. So we spread that 60 hectares over 10 years. So we've just run one scenario here. I'm going to go back now and copy that scenario, and we'll copy that scenario, and then we'll turn adoption on. Let's go in there, scrolling down, I'll change the name. We'll say realistic adoption levels and time. So all the same settings through here. Yep. Then we can save this one and run it. So what we should see with the result is that the overall speed to achieve the water quality changes will be flatter. So you can see that curve is flatter for the nitrogen. And we're actually not hitting the same peak as before because we're running out of available activities. So just to be able to look at that in a bit more detail, let's open the other one up in another tab so we can look at the shape. So this is running it without the adoption, so just the slope of that water quality response is a reflection of the time for the water quality change to happen without adoption. Now if we zoom in, get the same sort of thing at a local level, and then again without adoption. So that's the effect of having adoption represented.